Hi everyone, we're Team CodeCat Collective. So for our mechanical engineering project, we designed the reforestation robot ecosystem, an automated multi-robot system built to combat deforestation. Today's reforestation efforts are slow, labor-intensive, and often ineffective due to inconsistent planting and sapling care. Our solution includes five specialized robots. The seed planting rover ensures uniform depth and spacing. The soil analyzer bot collects data to boost germination rates. The sapling watering unit provides controlled hydration. The wildlife pest detector monitors for threats using motion and ultrasonic sensors. And the tree growth monitor drone tracks development from above. Together, these robots automate the reforestation process, improving efficiency and raising sapling survival rates to over 70%.
This is Malik Blanchard and I will be presenting to you the Soil Analyzer robot. Here is a 3D model of the Soil Analyzer robot. This depicts the Soil Analyzer robot traveling along its predetermined path to collect soil samples along plots where trees are supposed to be planted. The rover will be operated using the Arduino. There are 6 DC motors for rotating the wheels, powered by two 9-volt batteries. For sensing of its surroundings, it will be using an ultrasonic sensor. And for moving the arm, we use a servo motor. Movement will operate as such. When distance is greater than 20 inches, the rover will move forward. When distance is greater than 10 inches but less than 20, the rover will oscillate. To oscillate, the left wheels will rotate in reverse at half speed and the right wheels will rotate forward at full speed. To control the arm, it will start at an initial position of 90 degrees. When an input is sent through pin 7, the servo will operate clockwise. When an input is sent through pin 8, the rover will operate counterclockwise. This in turn will move the arm to collect the soil. The flowchart depicts the operation of the soil analyzer robot.
The rover is equipped with a shovel arm to move soil, two seed planting arms, a water reservoir, and an ultrasonic sensor, not a camera, to help it maneuver. The rover is propelled by four all-terrain wheels. Here, we see the rover shoveling dirt by using its shovel arm. Next, the rover positions itself next to the tilled soil. The arm will plant a seed and measure the soil for moisture content. If the soil does not contain enough water for the seed, the rover will deliver a small amount of water. The rover will then move onto a plot of dirt far enough away from the previously planted seed. My circuit required an ultrasonic sensor for maneuvering the rover, an ultrasonic sensor for measuring the soil, four DC motors to control each wheel, and a servo to control each shovel and seed planting arm. Here's my robot's control process. It will measure the distance between each seed, plant a seed, measure the soil for moisture and water if necessary before moving on.
Hi, my name is Antonio Ramirez, and this is my project, the Wildlife and Pest Detector. The Wildlife and Pest Detector is a four-wheeled mobile robot designed to detect and respond to intruders using basic mechatronics. The robot uses DC motors to drive its wheels and move across surfaces controlled by an Arduino and a motor driver. Mounted on the front is an ultrasonic sensor attached to a servo motor, which allows the sensor to sweep left and right to continuously scan the environment. When something is detected, the signal is sent to the Arduino, which decides what action to take based on the size of the object. If a large intruder like a person or animal is detected, the robot triggers a high-pitched sound from a speaker under the gray cone to scare it away. If a small intruder, like a bug, is detected, a water spraying system is activated. It uses a small, fan-like sprayer, tubing, and a water reservoir to spray and deter the pest. This part applies simple fluid mechanics. The entire system is powered by standard 9-volt batteries, which supply power to the motors, sensors, and processor through a breadboard setup. The Wildlife and Pest Detector brings together core concepts of mechanical engineering, including sensors, motion control, actuators, and system integration, to solve a real-world problem in an automated way. Hello, my name is Antonio Ramirez, and this is the Tree Growth Monitor, an autonomous drone designed to track plant health and growth over time. It uses four DC motors connected to an Arduino to power and control its propellers, allowing for stable flight. A pair of landing skids ensure smooth takeoff and landing. Mounted on the front is a high-resolution camera, a plant scanner, which collects real-time data on vegetation, health, and condition as the drone flies. The flight paths are pre-programmed, so it operates without human control. This design is the sapling watering unit, a compact, all-terrain mobile platform built on a rectangular chassis, about 2 by 30 centimeters. The structure uses simple 3D shapes, a box for the base, cylinders for the wheels, and a smaller box for the Arduino controller. At the front, we mounted a transparent watering tank, a DC water pump, and an adjustable nozzle controlled by a servo motor. A soil moisture sensor on a retractable arm.
The robots operate in Unity. The soil analyzer bot selects the best plots. The planter bot digs the holes and plants the seedlings. The sapling watering bot takes care of the saplings by maintaining water moisture, while the pest and wildlife control bot deters small pests and larger wildlife from damaging crops. Lastly, the wildlife monitoring bot monitors the entire operation. Here are the set benchmarks for the configuration. Value added: end-to-end operation for planting up to 2 years of survival of crops, and data-driven adjustments to maximize 70% and more on retention. In conclusion, our integrated swarm, automated forestation, tackling planting, soil care, watering, pest control, and growth monitoring. By meeting depth, soil moisture, and survival benchmarks, we address the core forestry challenges.